Okay, hello everyone. Uh, Today I'm going to be showing you something interesting, very simple and quick, which is an interactable object, which you can use, for example, like a lever. So, let me just go ahead and open Magicka for a moment, and I'll be showing you exactly what is it that I'm talking about. So, I've been trying to make a very simple, most easiest to set up or reproduce setup for people who want to make levers, and this is the way to go. So let me just load things up for a moment, and here we are. Okay, so let's go ahead and kill this guy. And here is our lever, and you can see that it says interact, and we can go ahead and interact with it, and well, it's kind of wonky at first because I haven't set up the XML file properly, but after that it works just fine, right? So as you can see, every time I interact with it, there's a 1.5-second delay before I can interact with it again, and I can move it up and I can move it down, right? So yeah, pretty cool. Let me go ahead and show you the code. Here it is. It's very simple. All you have to do is have some on interact for every single action that you want to do. Well, before we go to see the code, actually see the setup in the scene. So for the scene, we have a bone, which is the lever bone, right? And attached to it, we have a mesh to represent the lever, right? And we have two keyframes. I actually added a third one in the middle. You don't need that. You only need two keyframes, right? And those keyframes right here are the start and the end. The reason I added this one in the middle is to prove something I will be explaining to you in a moment. So we got the start keyframe and the end, and the animation looks like this, right? And every single animated level part can only have one single animation, right? Children parts can have their own animations, but this part only has this animation right here. But the cool thing about it is that we can play it backwards, right? And that means we can repurpose it to do stuff one way and the other. And after you have set up your lever bone, you can add a radius to it. You can change if it has collision or not. Ideally, a lever would not have collision, but we enabled it in this case, and it can look kind of wonky when the lever hits your head and moves you aside, but yeah. And we got the mesh right here, etc., right? And apart from that, what we need is two POIs, which are the POIs, which are just locators, and we'll use them as a way to control the logic of moving up and down the lever. And they can be pretty much anywhere, but it's interesting to put them near the object that you're controlling to be able to locate them easily. And you will have one called lever down and one lever up, and each of these are in charge of doing precisely what their name says. The POI lever down in this case is going to be the one responsible for moving the lever down, and the one that says lever up is going to be the one that moves the lever up. And if we go over to the code, we can see the levers. They are with their own interacts. We have the locator, which is basically just a dummy entity used to contain the interaction code, to be honest. So that's just the way the things work. They are called locators, but they don't really even use any location data for them to work, but whatever. The type is of type interact, and the anim highlight has to be the name of your bone, right? And within here, you can put any piece of code you want, but the code that we have located in here is very minimal. It only plays the animation and disables this POI right here, so that we cannot move the lever down once we have already moved it down, because it would play the move down animation twice, and that's not what we want. And it enables the other POI to move it up, right? And we have a delay of 1.5 seconds, which means that we're gonna have to wait that much time for the other POI to be enabled. So it's going to give us this breathing room until it enables. So you should look at how long your animation is and how much breathing room you want to add to tweak this value correctly. And on the other, on interact, to move the lever up, we got the exact same code only that this time the play animation code it starts at 1 and ends at 0, and it has a delay of 0 and a speed -1. So what this means is that we start, I interpret this originally as starting at frame 0 and ending at frame 1, or starting at frame 1 and ending at frame 0. No, basically this is like a lerp value. This is like a percentage, right? And starting at 0 would mean that we start at 0% of the animation. At 1 would be 100% of the animation. So when we do it the other way around, it means we're starting from the last frame and we're going to end on the first frame, right? And this thing right here, the speed -1, is the important part, which is what controls that we're going to be playing the animation backwards. You can change the speed with a multiplier. You could have 1.5 to make it go faster, or times 10 to make it 10 times faster, or you could put in 0 point something to make it slower, or if you put a negative value, you make it play backwards, right? So it's very simple, and to be able to actually do this, because all poise start enabled by default, by the way, since you want to disable them, you gotta make sure that one of them is enabled and the other is disabled, right? And in this case, I did it the other way around, but basically in the trigger corresponding to the start, you would have a disable poi to the poi that you don't want to be able to use at the start. And since the lever starts pointing upwards, that means that the action we're going to do is pull downwards. It should be lever up, the one that is disabled. I actually wrote that wrong before, so this should work now. And now that we have that, it should be pretty minimal and reproducible setup to actually make yourself have a lever that you can move up and down and use however you want. And I already activated it because the radius is pretty big, so I can activate it from up here. Obviously you gotta tweak the radius, and as you can see, it's working pretty nicely. And obviously we could insert any other code we want within it to be able to do anything, but right now for me it's enough to move the lever up and down. At some point, because right now if you realize this lever has collision, right? So it's just a lever. But this is, in essence, the exact same code that you would use with an interactable door that would open up when you press it, right? So you could have a door and you press it and you open the door, you press it again, you close the door, and you know, you could also add more code to trigger other events or do anything you want within the on interact code, etc, etc. There's so much stuff that we can do with this. So yeah, it's pretty cool. It's a minimal reproducible system to make a lever, and hopefully you people can find it useful and make use of this in your levels when using this tooling. So yeah, pretty nice. And of course, all of the things that I mentioned before about this thing right here apply the exact same way. So yeah. Oh, and by the way, before I go, I wanted to, well, mention a little bit some changes that there's been to the code, but it's not really important. It's just that we now make use of the parent transform to make sure that when we compute every single frame, we actually do it within the correct animation frame, right? Like the correct reference system, so that we get the correct coordinates when we compile the file. So yeah, that's just a tiny change that we've made use of. And since we pass in the object and the relative transform, we don't pass in the parent, because the parent object is not the same as the actual parent in the Blender hierarchy. When we talk about parent, we would be saying that every single object below a bone would be its, you know, a children of that bone. Thus, the parent of those children would be that bone, even though within the Blender hierarchy there could be empties in between, right? So as to not mess things up, we compute that relative transform before on the get stage, and here we just recompute the parent transform by making use of this inverse matrix, right? So maybe it's not the best way to do things, and we should carry it around, but all of the functions are programmed to take in one object and one relative or global transform. So I didn't want to have to recode the entire system, so we just compute it like that. But yeah, thanks for watching.